Okay, what are the domain and range of this expression? 1 over x squared plus 1. So, by convention, the domain is all x, so this makes sense. Are there any problems? Well, I don't think so. So, x squared plus 1 makes sense for any number x. We are taking the reciprocal, so 1 over it. But notice that x squared plus 1 is also greater than or equal to 1. So that means it can't be equal to 0. Remember, x squared is always positive. So this implies x squared plus 1 does not equal 0 for any x. So we have no problems. So this implies the domain is equal to what? It's everything. The whole real numbers. Nothing at all is a problem. So I think that's quite straightforward, right? You just look around the expression and think, what could go wrong? The only thing that could really go wrong is I would divide through by 0, but that can't happen because it's x squared plus 1. If it was x squared minus 1, we'd have problems. You'd have issues at 1 and minus 1 because you'd be dividing through by 0, but you don't have that here. Now, a lot more difficult is the range. And this is a problem which we can solve, but it's kind of, we're very lucky to be able to do it. So let's just remember what we've seen a moment ago. The range of the function x squared plus 1, that's equal to what? It's equal to 1 onwards, isn't it? Now, what does this mean? That means when I'm taking this expression here, I am going to be dividing through by absolutely everything here. Right? These are all the possible values x squared plus 1 can take. So what does that look like? Well, if I take 1 and divide it by one of these guys, something in there. Well, first of all, if I start at 1 here, well, if I divide 1 by 1, I would get 1. What happens as I get bigger? Well, as I get larger, I'm dividing up here by something bigger than 1. It's going to get smaller, isn't it, right? So, for example, if I chose a value for this which was 2 in here, it would be a half. And if you think about it, as the denominator gets bigger and bigger and bigger, this is going to get smaller and smaller and smaller. Smaller and smaller and smaller. And there's no limit to how small it gets, in a sense, right? It can be absolutely tiny. It'll never hit 0, though, because the only way you could be a 0 fraction is if the numerator is 0. So that logic, and this is pretty tricky, this tells us the range, the range of 1 over x squared plus 1, well, it has to start at 1. That's kind of corresponding to dividing through by 1 here. But then as I get bigger, I'm going to get smaller and smaller and smaller. And I'm going to go through all values, all the way back to 0, but I'm not going to include 0. So this is a pretty tricky example, right? And if I gave us a more complicated expression up here, we'd be really in big trouble. So this is a good example of quantitative reasoning, right? This isn't just a cold calculation. This is really thinking, what is the meaning of range? And why does the range of this guy have a bearing on the range of this guy? So it's all about understanding that the possible values in the denominator here occur in here. And I'm just thinking about what happens when I divide something, or divide 1 by something in here. Well, it starts off at 1 and then it gets smaller and smaller and smaller. So this is a difficult question. If I changed it a little bit, it would be much more difficult to solve. In fact, not really possible at the pre-calculus stage. So even a change as small as this, for example, determining the range then is just much more difficult because the ratio is more complicated, because x squared over 1 on the bottom, yeah, it's still in this territory, but now I'd be dividing through by x, so it's much more complicated what happens to the ratio. So finding ranges in general is very difficult. Domains will be easier, it'll still be difficult, but it won't be as hard.